Yes, the story is plausible. It is possible for a severe electrical fault to cause a main breaker to trip, then reignite when the breaker is flipped back on. This can lead to a catastrophic fire if not handled properly. A main breaker is a safety device designed to open the circuit when an excessive amount of current flows. When it trips, it means there is a problem downstream. Flipping it back on without further investigation can be dangerous because the fault may still be present. Possible causes of a main breaker tripping and then igniting upon reset include firstly, a short circuit, which is a direct connection between the hot and neutral wires, creating a path of high current. Secondly, overload, drawing too much current through a circuit, causing it to overheat. Thirdly, a ground fault, current leaking to ground, typically through a damaged wire or appliance. Fourthly, arcing, which is electrical sparks caused by loose connections or damaged insulation. Fifthly, an internal fault, a problem within the breaker itself, such as a melted contact. To prevent a similar accident, follow these steps. Firstly, always test before resetting. Use a multimeter or voltage tester to check if the voltage is present across the main breaker terminals. If there is no voltage, the fault is likely downstream. Secondly, inspect the panel. Check the main panel for any visible signs of damage, such as burnt wires or loose connections. Thirdly, identify the source of the fault. Use a circuit tester to trace the affected circuit and identify the problem appliance or device. Fourthly, fix the problem. If possible, fix the fault, for example, replace a blown fuse, tighten loose connections. Otherwise, call a qualified electrician. Fifthly, reset the breaker cautiously. Only flip the main breaker back on once you are confident the fault has been fixed. Monitor the panel for any unusual sounds or sparks. Additional tips include 1. Use a breaker with a higher amperage rating than the maximum load on the circuit. 2. Regularly inspect and maintain electrical panels and components. 3. Contact a licensed electrician for any major electrical repairs or upgrades. Electrical safety is extremely important, and knowing how to handle a trip breaker safely can prevent potential fires and injuries. A short circuit occurs when there is an unintended low resistance path for current to flow, bypassing the intended load. This results in a very high current flow, exceeding the breaker's rating and causing it to trip. Common causes include damaged insulation on wires, loose connections, or faulty appliances. An overload happens when a circuit draws more current than it's designed to handle. This can occur when too many appliances are plugged into the same circuit or when an appliance malfunctions and draws excessive current. The excessive current causes the wires to heat up, potentially damaging the insulation and creating a fire hazard. Ground faults occur when current leaks from a hot wire to a grounded surface, such as a metal enclosure or a water pipe. This can happen due to damaged insulation, moisture, or faulty wiring. Ground fault circuit interrupters, also known as GFCIs, are designed to detect these faults and quickly trip the circuit, preventing an electrical shock. Arcing is a phenomenon where electricity jumps across a gap between two conductors. This can be caused by loose connections, corroded contacts, or damaged insulation. Arcing generates heat and can ignite flammable materials, leading to a fire. Arc fault circuit interrupters, known as SCIs, are designed to detect arcing and trip the circuit, preventing fires. An internal fault within the breaker itself can also cause it to trip and potentially ignite. This can be due to manufacturing defects, wear and tear, or damage from previous overloads or short circuits. Regular inspection and maintenance of electrical panels and breakers are crucial for identifying and addressing potential problems before they lead to dangerous situations. When a breaker trips, it's essential to investigate the cause before simply resetting it. The first step is to visually inspect the electrical panel for any signs of damage, such as burnt wires, loose connections, or discoloration. Use a multimeter to check the voltage at the breaker terminals. If there is no voltage, the problem may be upstream, such as a problem with the utility supply. If there is voltage, the fault is likely downstream, within the branch circuit. Disconnect any appliances or devices in the affected circuit. Then use a circuit tester to check for continuity between the hot and neutral wires, as well as between the hot wire and ground. A low resistance reading indicates a short circuit or ground fault. Once the fault has been identified and corrected, the breaker can be reset. However, it's important to monitor the circuit closely after resetting the breaker to ensure that the problem has been resolved and does not recur. If the breaker trips again, it's essential to call a qualified electrician to investigate further. Using a breaker with a higher amperage rating than the maximum load in the circuit can be dangerous. The breaker is designed to protect the circuit from overloads and short circuits. If the breaker is too large, it may not trip in time to prevent damage to the wiring or appliances. It's important to calculate the maximum load on the circuit and choose a breaker with an appropriate amperage rating. Regularly inspect and maintain electrical panels and components to ensure that they are in good working order. This includes checking for loose connections, corrosion, and damage to wiring or insulation. It's also important to keep the electrical panel clean and free of obstructions. Contact a licensed electrician for any major electrical repairs or upgrades. The electrical work can be dangerous and should only be performed by qualified professionals. A licensed electrician has the knowledge, skills, and experience to safely and effectively perform electrical work. Electrical panels are typically located in a basement, garage, or utility room. They serve as a central distribution point for electricity in a building. The main breaker in the electrical panel controls the flow of electricity to the entire building. Branch circuit breakers protect individual circuits within the building. Each circuit is designed to supply power to a specific area or group of appliances. The amperage rating of a breaker indicates the maximum amount of current that the circuit can safely handle. When the current exceeds the breaker's rating, the breaker trips, interrupting the flow of electricity. This prevents the wiring from overheating and potentially causing a fire. Electrical codes and regulations, such as the National Electrical Code, also known as NEC, provide guidelines for safe electrical installations. These codes specify the types of wiring, breakers, and other electrical components that are required for different applications. It's important to comply with electrical codes to ensure the safety of the electrical system. Grounding is an important safety measure that helps to prevent electrical shock. Grounding provides a low resistance path for current to flow in the event of a fault. This allows the breaker to trip quickly, interrupting the flow of electricity and preventing a dangerous voltage from building up on metal surfaces. Grounding systems typically consist of a grounding electrode, such as a metal rod driven into the ground, and a grounding conductor that connects the electrical panel to the grounding electrode. Surge protection devices, known as SPD, protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, power outages, or other disturbances on the electrical grid. SPD divert the excess voltage away from sensitive equipment, preventing damage. SPD can be installed at the electrical panel or at individual outlets. Proper wiring techniques are essential for ensuring the safety and reliability of electrical systems. This includes using the correct wire gauge for the circuit, making secure connections, and protecting wires from damage. It's also important to follow the manufacturer's instructions for installing electrical components. Regularly testing ground fault circuit interrupters, or GFCIs, is important to ensure that they are working properly. GFCIs are designed to protect against electrical shock by quickly tripping the circuit when a ground fault is detected. GFCIs should be tested monthly by pressing the test button on the device. If the GFCIs does not trip, it should be replaced immediately. Aluminum wiring was commonly used in homes built in the 1960s and 1970s. However, aluminum wiring can be prone to corrosion and loose connections, which can create a fire hazard. If a home has aluminum wiring, it's important to have it inspected by a qualified electrician. The electrician can determine if the wiring is safe or if it needs to be replaced with copper wiring. Knob and tube wiring is an older type of wiring that was commonly used in homes built before the 1940s. Knob and tube wiring is not grounded and can be prone to deterioration. If a home has knob and tube wiring, it's important to have it inspected by a qualified electrician. The electrician can determine if the wiring is safe or if it needs to be replaced with modern wiring. Electrical safety is a shared responsibility. Homeowners, renters, and contractors all have a role to play in ensuring that electrical systems are safe. By following safe electrical practices and taking precautions, it's possible to prevent electrical fires and injuries. When working on electrical circuits, it's essential to turn off the power at the breaker before starting any work. This will prevent electrical shock. It's also important to use insulated tools and wear safety glasses. Never work on electrical circuits when wet or standing in water. Always assume that electrical circuits are live, even when the power is turned off at the breaker. Use a voltage tester to verify that the circuit is de-energized before starting any work. When replacing a breaker, it's important to use a breaker with the same amperage rating and voltage rating as the original breaker. Using a breaker with a higher amperage rating can overload the circuit and create a fire hazard. When making electrical connections, it's important to use the correct type of wire connectors. Wire connectors are designed to provide a secure and reliable connection between wires. Using the wrong type of wire connector can result in loose connections, which can create a fire hazard. When running wires through walls or ceilings, it's important to protect the wires from damage. Wires should be run through conduit or other protective materials. This will prevent the wires from being damaged by nails, screws, or other objects. When installing electrical outlets, it's important to follow the manufacturer's instructions. Electrical outlets should be properly grounded and securely mounted. Using a licensed electrician is highly recommended for all electrical work. A licensed electrician has the training and experience to safely and effectively perform electrical work. Hiring a licensed electrician can help to prevent electrical fires and injuries. Electrical fires can be caused by a variety of factors, including faulty wiring, overloaded circuits, and damaged appliances. Electrical fires can be very dangerous and can quickly spread throughout a building. It's important to take precautions to prevent electrical fires. Smoke detectors are essential safety devices that can help to save lives in the event of a fire. Smoke detectors should be installed on every level of a home and tested monthly. Fire extinguishers can be used to put out small fires. Fire extinguishers should be readily available and homeowners should know how to use them. In the event of an electrical fire, it's important to evacuate the building immediately. Call emergency services from a safe location. Do not attempt to put out an electrical fire with water. Water is a conductor of electricity and can increase the risk of electrical shock. Regular electrical inspections can help to identify potential problems before they lead to dangerous situations. Electrical inspections should be performed by a qualified electrician. The electrician will inspect the electrical system for any signs of damage, wear and tear, or code violations. Based on the inspection, the electrician can recommend any necessary repairs or upgrades. Staying informed about electrical safety is important for protecting yourself and your family. There are many resources available online and in libraries that can provide information about electrical safety. By taking the time to learn about electrical safety, it's possible to prevent electrical fires and injuries. In conclusion, electrical safety is a critical aspect of home ownership and should never be overlooked. Understanding the potential causes of electrical hazards such as short circuits, overloads, and ground faults is the first step in preventing accidents. Regular inspection and maintenance of electrical panels and components are essential for identifying and addressing potential problems before they escalate into dangerous situations. When a breaker trips, it's crucial to investigate the cause before simply resetting it, and it's always advisable to consult a qualified electrician for any major electrical repairs or upgrades. By adhering to safety guidelines and taking precautions, it's possible to minimize the risk of electrical fires and injuries, ensuring the safety and well-being of yourself and others. Remember, electrical work can be dangerous, and it's always best to err on the side of caution. If you're unsure about any aspect of electrical safety, don't hesitate to seek professional help. Your safety and the safety of your property are worth it.